Making assumptions in SD. The the cardinal rule about assumptions is this. Whenever you make an assumption, make sure you know how you're going to discharge it. And by discharge it, what we mean is how you're going to end that subderivation that you introduced and return to the main derivation so that you can reach your overall goal. Um, if you are just making assumptions blindly, then what you're going to end up doing is burying yourself in subderivations. And if you're stuck inside subderivations, you're not getting closer to your goal. So you always need to make sure that you know how you're going to get out of that subderivation and make use of it. So this is why, when you make an assumption in SD, you have to write in the rule that you're making that assumption for. This is, to force you to think about why you're making this assumption so that you're not just doing it blindly. But more specifically, if you've got a goal sentence, then, here are there's some heuristics about the assumptions that you're going to want to make. So you look at the form of your goal sentence, and so if your goal sentence is a conditional, you're probably going to want to use conditional in production. Right. So you would set up a subderivation where you assume the antecedent of the conditional, you put the consequent of the conditional at the bottom, and then you try to link up the top and bottom of that. If it's a conjunction, then set up for conjunction introduction. Put the two conjuncts on, above that, and then try to work out how you're going to derive those. If it's a biconditional, then use biconditional introduction. So set up the two subderivations, one that goes from one side to the other side, and then the other one that goes in the other direction. If it's sentence letter, a negated sentence letter, or a negated compound sentence, then negation elimination or negation introduction, those are going to be your best bets most of the time. If it's a disjunction, then one possibility is disjunction introduction. You have to look very carefully at the disjuncts here and think, could you actually prove one of these and then use disjunction introduction? If you think you can prove one of the disjuncts, then go with that, right? Try to prove one of the disjuncts and use disjunction introduction. A lot of the times, though, that doesn't actually work. You will not be able to prove one of the disjunction or one of the disjuncts. You'll have to prove the entire disjunction. And in that case, negation elimination is going to be your best bet, or will frequently be your best bet. So assume the negation of the disjunction and try to derive a contradiction. If you're not sure about what the best way to go here is, sometimes you want to construct or one thing that can help here is constructing a truth table. Look to see if, for example, if you're trying to prove a theorem, look to see if one of the disjuncts is actually a theorem, something that you could prove, right? Or look to see if it is actually entailed by previous lines in your derivation. You can see if it's truth functionally entailed by previous lines with a truth table. And because of the fact that SD is sounding complete, that means that you can derive them from previous lines. So, that you would be able to use disjunction introduction in those cases. If neither side of the disjunction is truth functionally entailed, then that's not going to, that the derivation isn't going to work. In a later video, we'll look at an example of using truth tables to guide building derivations. Um, okay, if you have a disjunction at the top of your derivation, then often disjunction elimination is a good idea. So set up two subderivations, assuming each of the disjuncts, right? One assumes one disjunct, the other assumes the other disjunct, and then try to derive the same goal sentence in both of those, and then use disjunction elimination to infer that. And if at any time you have two lines at the top of your derivation that contradict each other, right? Where one of them is the negation of the other one. If you get this at any time, then use the principle of explosion. Just assume the opposite of your goal sentence. For negation introduction or negation elimination, reiterate those two lines into that, and that's how you're going to get your goal sentence. Um, One important thing to note here, right? These heuristics overlap. So, like for example, if your goal sentence is a disjunction and you've got a disjunction at the top of your derivation, right? Then if you look at these heuristics, right, what it says is you could use negation introduction, negation elimination, or disjunction elimination, right? Any of those would be possible. Um, Constructing derivations isn't a mechanical procedure, right? There are always decisions that you're going to have to make. And one thing is that as you practice working with SD, you'll get a better sense of what the optimal strategy for finishing derivations is going to be. Like I was saying when we are talking about when your goal sentence is a disjunction, truth tables can often guide your decisions. Um, I mean, there are many derivations that you can solve by just sort of blindly applying these heuristics, right? Where you have a conditional, so you just apply that, you just apply conditional introduction, and then your new goal sentence is a sentence letter, so you just use negation elimination, right? Assume the negation in the sentence letter. And you can go through just blindly doing things. That sort of thing does happen, but it's, pretty rare. Most of the time, it does take some creativity and some ingenuity to complete derivations. The key thing is that if you're going about it right, what you want to do is you want to keep the ingenuity to a minimum, right? You want it to be as close to a mechanical procedure as possible. And, so want to, you don't have to think about it any more than you have to, right? The more that you can minimize that, minimize the hard problems, the better you're doing, the easier things are going to be.